6.4 Performance Feedback. So here you can see the data that I'd gathered from the numerical model. Your performer is the first participant on the table, so that's the performer here. So you can see all their results across this way. And these kind of ovals are just to highlight certain things that perhaps were advantages or disadvantages of your performer's performance. So there's some key points you can gather from this data. This is in relation to the braking impulse, the propulsive impulse, and just their general velocity. So a high propulsive impulse is advantageous as it propels the performer forward. In this case, the performer has a high propulsive force, which obviously is going to be very advantageous. They get that good initial force coming out of the starting blocks during this sprint. However, the performer also has a high braking impulse. So a high braking impulse is disadvantageous as it slows the performer down. It means that they're not going at their full speed. So the performer also has a high braking impulse, which is negative. Lastly, you can see this relationship over here between velocity and the angle at their knee. So when they have the smallest angle at the knee, which was 126, this actually resulted in the lowest velocity score of 3.94 meters per second. This would imply, therefore, that the smaller the angle, the smaller the velocity. This might be more relevant when looking at a technical model, so you can actually compare it and compare that technique of the angle at the knee. But I'm actually going to focus on the propulsive impulse compared to the braking impulse. So if we move on to have an actual closer look at this, you can see that throughout every single sprint, the braking impulse is actually higher than their propulsive impulse. Now in a sprint, the performer would want to have a larger propulsive impulse than the braking impulse. So you can see here that there must be something wrong with the technique of the performer. Perhaps they're going too flat-footed when they're sprinting. Most professional sprinters would be up on their toes as they sprint forward, creating more of a horizontal propulsive impulse as they push off, as opposed to that flat-footed vertical force of the braking force. This braking impulse is obviously putting the performer at a loss of velocity. So we've looked at the forces exerted by that performer and how they impacted their velocity during this sprint. So let's actually have a look at the specific velocities at certain points in this sprint. If we look at certain sections, you can see the times here is broken down over the distances. So I've highlighted the performer here in yellow, so it's easier for us to determine the difference between the rest of the performers. Some of the main things you can gather from this data is that through every 20-meter sprint, the performer is actually fastest between 11 and 15 meters. So you can see here they constantly, through every sprint, they are getting their fastest time during that 11 to 15 meters. This 11 to 15 meters is obviously towards the middle of the sprint. So this would imply that the performer's acceleration or their reaction time is a weakness. As you can see that their slowest point is at the start of their sprint. Comparing this to the other performers though, you can see that your performer is actually quite average between the others. So they're not the fastest, but they're not the slowest. This is obviously reiterated in the force plate data, as you can see that in some things they're better and some things they're worse. So their propulsive impulse average was actually the highest of all of the performers, as was their braking force though, which is not good. and their velocity was actually the worst. Their horizontal 5-meter velocity, as shown here, they actually had the lowest velocity of all the performers. So you can see that some things they're better at than the rest of the performers, and some things they're worse at. So let's take a closer look into what they're better at. So they obviously have a high propulsive impulse, and that's obviously advantageous, as we've said before, as it propels that performer forward. So your performer has a high propulsive force, but a higher force would improve your sprint time still. So if you can improve that propulsive impulse, it's always going to improve your sprint time. So it's always worth trying to improve that propulsive impulse. Performer was also very consistent, as you can see here, in their velocity. There wasn't any flukes or anything which would show that they'd be very good in a game situation. They wouldn't have one good sprint and then be tired out for the rest of the game. They would actually be able to consistently continue making those sprints throughout the game. As you can see here, their standard deviation number is very low compared to the other two performers. Taking a look at the weaknesses now though, so you can see that the performer actually took the longest time to reach 5 meters out of all the performers. Again, this implies that their acceleration is very poor because that initial starting 5 meters was very slow. Like I mentioned before, another weakness is that they had a very large braking force and braking impulse. This is obviously negative as it slows the performer down and means they're not accelerating forward. They actually had the largest braking impulse on average out of all the performers assessed. If we look into notational analysis now, so you can see this is the basic data that I gathered when actually assessing this. You've got a basic data collection sheet and we have a schematic here of the movement of the performer, which actually looks very good on this side. Perhaps a bit more movement over here, but if they were playing as a small forward, they might just be on this side of the court, which is perfectly fine. They're clearly making a lot of darting runs back and forth. So looking at this data now then, we're actually looking at the left side of this graph on each of these graphs. That's the performer we want to focus on. And then on the far right side, we have the averages. This player in the middle isn't really relevant to this data analysis. So you can see here that the performer we're looking at is actually below average in everything except the number of blocks completed. So this would obviously imply that blocking is a strength of this performer and that the rest are weaknesses. Despite them being close to average, they are below average. However, as you can see here, I did look into the correlation between height and defensive rebounds. So your performer was actually on the shorter side compared to the rest of the team, who had height on their side as an advantage. You can see actually that there is a slight correlation. So a perfect positive correlation would be a score of 1. And no correlation at all would be a score of 0. So you can see here that actually there is a slight correlation between height and defensive rebounds. So this would imply that the taller people have an advantage over your performer. So if we take a look into the specific strengths and weaknesses from this notational analysis, you can see that their strengths were blocks and their movement on the court. And their weaknesses were their defensive rebounds, their shooting, so that's both 2-pointers and 3-pointers, and their steals. So like I mentioned before, defensive rebounds, your performer had that slight disadvantage of their height. So perhaps if we get that power improved, or that, like we mentioned before, that propulsive impulse to push them up from the ground and make them jump a bit higher, they would perhaps make more steals or catch those defensive rebounds. Shooting, however, their shooting was actually more to do with their technique, because it wasn't like they weren't shooting. They did take shots, they just missed them a lot more than they scored them. So if we move on to this technical model data now then, so we have the preparation phase, we have the execution phase, and we have the recovery phase. So you can see here all of these coaching points to each of the preparation, execution, and recovery phase. So you can see the strengths and weaknesses down this side for each phase. But if we go into specific detail here at the main strengths and the main weaknesses, because you obviously can't focus on and develop each and every point at this stage when we're trying to make such big improvements. So the main strengths here were they kept a low centre of gravity. So this obviously meant that they couldn't be pushed off the ball and pushed off balance, couldn't fall over. They also maintained contact with their player. This meant they knew where their player was at all times, so the player couldn't get round them or couldn't get away from them to beat them to the ball. And they also had both hands on the ball when they caught the ball in that recovery phase, and this obviously means that they're not going to lose the ball if they keep their hands on the ball. Their weaknesses, however, so in that preparation phase they do actually need a wider barrier. They're not spreading their arms out wide enough, as you can see here. Their arms are actually quite close to their body. They need to be spread out a lot more, and their legs need to be spread apart a bit more. So this wider barrier would obviously improve their balance and obviously again mean they wouldn't be pushed off the ball. It would also mean that their player can't get past them, as they actually have literally a physical barrier in their way. They also need a higher jump. You can see here in the execution phase, they've barely taken off of the ground here. So that's obviously going to be very disadvantageous, because if their performer's jumping higher than them, if they're not jumping high enough, their other performer, their opposition, is going to reach that ball before them. And finally, they need to distribute that ball sooner. So in this recovery phase, you can see that their teammate is being marked already. So they don't have that option to pass there anymore. They're already being marked. So they do need to release that ball sooner. So overall then, if we were to review everything, you can see that the strengths from notational analysis was their blocks and their movement. From the technical model was the low centre of gravity, maintenance of contact, and both hands on the ball. And from the numerical model, the highest average repulsive force of the performers and the smallest standard deviation. If we look at the weaknesses then, from notational analysis, we've got defensive rebounds, we've got shooting, which we will focus on for them to develop, because that is a very important factor as a small forward in basketball. And we have steals. So looking at the technical model, their weaknesses was that they needed a wider barrier. They needed a higher jump, which again I will focus on, because we noticed that that propulsive impulse in both this jump and that sprint was something that could be improved on and would obviously be advantageous for both of those skills. And they need to distribute the ball sooner. And finally, for the numerical model, the weaknesses were that high braking force, that slow acceleration, and that smaller propulsive force than braking force, which obviously would mean that that braking force was slowing them down, as instead of propelling them forward with that propulsive force.